All right, so now that we're becoming a little familiar with the polar coordinate system, where we're going to have a negative, we can have a negative radius, we can have positive radiuses based on where the pole is, which is basically a radius of 0 with an angle of 0 as the smack dab middle of it. What we're going to look at now is how does the rectangular coordinate system and the polar coordinate system convert between each other. So what I'm going to do first is I'm going to convert a polar point to a rectangular point. So let's say I have a polar point of 6 comma pi over, where's my example, pi over 6. And I want the same point in the rectangular system. Well, we know in the polar system there's an infinite amount of points, but in the rectangular system, one point only occurs in one spot. They are distinct. They're not multiple points that are 1, 1 on the xy plane. There's only one of them. So there's only one point that's going to match up to 6 comma pi over 6 to the polar plane. What we need to do is know some conversion factors. Well, these are pretty straightforward. We're going to have my x value is going to be r cosine theta. My y is going to be r sine theta. We should have already seen these before. If you think in our unit circle, our definition for our unit circle is cosine of theta equals x over r, but the radius is 1. That's why it's cosine is the x value on your unit circle. And then sine theta is y over r. Well, if I just multiply both these by r, I get these. Voila. All I have to do now is just plug them in and find the coordinate. So for my x value, I'm going to do my radius, which is 6. And I'm going to do cosine of pi over 6. Well, this is a unit circle, so I've got 6 times. Well, on the unit circle, cosine of pi over 6, last time I checked, it is square root of 3 over 2. When I reduce this, I have 3 square root 3. Now, this is for my x. For my y value, I'm going to do 6 times sine of pi over 6. Well, this once again is on the unit circle. So I'm going to get 6 times 1/2, which is going to be 3. So this coordinate on the xy plane is 3 square root of 3 comma 3. Not terribly bad. Not terribly bad at all. You just have to know these two formulas, identify what your radius is, what your angle is, and plug it in and chug out an answer. All right, let's do another example of converting polar coordinates to rectangular coordinates. So let's say I have a polar coordinate of -4, negative pi over 4. All right, so here my radius is -4, and my angle is negative pi over 4. Well, what's really nice about my formula is where x equals r cosine theta and y equals r sine theta, is I just plug and chug. I don't care about the negatives. So I want to plug this in, and I'm going to get -4 cosine of negative pi over 4. Well, cosine's an even function, so I can use the even-odd identity, and I know that the negative sign doesn't matter. It goes away. So I got -4 cosine of pi over 4, which then is on the unit circle. I have -4 times the square root of 2 over 2. Which gives me -2 square root of 2. And there's my x value. All right, now we're going to do the same thing for sine. We're going to just plug it in and go. We've got -4 sine of negative pi over 4. Sine is an odd function. From our even-odd identity, we know the negative can come out, and a negative times a negative becomes a positive, so this changes to 4 sine of pi over 4. Sine of pi over 4 is on your unit circle, which is 4 times the square root of 2 over 2. Which gives me 2 square root of 2. Therefore, my xy coordinate of -4 negative pi over 4 in the polar form, the rectangular form, is going to be -2 square root of 2 comma 2 square root of 2. And we're done. Pretty straightforward. Hi, I'm Mr. Buzzer, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.